so that we have this in perpetuity and for posterity of the process. And yeah, so that's kind of the general goal for today. Any questions or comments before we dive into the agenda? All right, not hearing any at the moment. I will go ahead and share my screen. And in doing so, give it to see the agenda. And next up, I will bring up the first item, if I can go. I can enlarge the size of the text here. And so this is proposal P12.4 C403.8 fan and fan controls. This is Mr. Fulton's proposal. And with that being said, I'll scroll down and Mike, I'll turn it over to you to do an introduction and an overview to the language. If you need me to scroll one way or another further, please just let me know.
Okay. Mike Fulton, Western Mechanical Solutions. This is a pretty simple proposal. It is for intermittent exhaust control where allowed by the IMC. And basically it's for bathrooms and toilet rooms. And the concept is that there's a timer. Timers cost about $15 at Lowe's with multiple time settings on them. It's, you know, if you go into the bathroom and your timer or your fan is on a switch, often you leave the fan running, you forget to come back. 2 hours later, you go back either when the noise has annoyed you or with super quiet ones, you know, you might not remember for a while. There are some really quiet bath fans out there. And so this just will reduce energy because what's happening is you're basically bringing your building negative and having to condition that air that you're exhausting. So, so for 50 CFM, you know, we ran through some bin analysis. It's about $27 a year. If you went from 5 minutes of runtime, which is about what my family's figured out, to 2 hours. So it's a pretty economical, you know, on a new construction project, it'd be, you know, $15 for the switch. On a retrofit, it'd be a little bit more. And then there's some exceptions for having an occupancy sensor or humidity sensor if you wanted that, and contaminant control as well. So we actually worked a bit with Brown, the national exhaust fan manufacturer, to come up with some justification of this as well. And some of those notes and precedences are listed. So I think with that, that's all I have for justification. Oh, and one other thing, it was brought up that people were worried about this being applied to exhaust systems where you're using the exhaust fan as ventilation. And so that was specifically accepted.
All right, does anyone have questions or comments? Again, a bit less informal in this in this conversation, so feel free to jump in with either Chuck, Bartel. Go ahead, please.
Yeah, thank you, Eric, and Mike. Thanks for your proposal. 2 questions. One, it appears that Section C407 currently would not have this required in if you used a performance model. So this would only apply to prescriptive paths. And I just wanted to verify that the proponent was good with that. And then also if, Mike, can you give a real world example of number 4, the contaminant control that responds to particle or gaseous concentration? How would you envision that being applied in the real world in a bathroom or toilet room?
Yeah, so we're proposing this nationally as well, and this was a big thing that Brown wanted to apply. And so their notes and precedences down below actually talk about, for instance, CO2 does not, demand control ventilation does not tell anybody what you need to trigger the onset of demand control ventilation. So it is purposely broad for different applications, with that kind of concept in mind, that, if you want to put in something that's going to trigger at 2.5 particle size, you can, or if you want to have it for VOCs, you can. So it is purposely broad.
Do you feel that though, like CO2 or VOCs exhaust, I mean, typically restroom exhaust and toilet room exhaust is not intended for that type of ventilation for like CO2 or VOC. It's more
Yeah,
moisture and odor control. And so I was curious on where that number 4.
Yeah, and number 4 probably. So we're suggesting this at the commercial and residential level, and that's one thing I did want to mention, is I think this would make a lot of sense to apply to a residential code as well, and that's maybe where number 4 would apply more than in a more of a commercial application. The sensor itself is quite a bit more expensive, so I don't see this being readily adopted. Generally they're a couple $100 versus you're talking $15 for a timer.
I've got a question, Mike, just with respect to the humidistat, the cost, and then maybe the payback associated with runtime there. Of course, being in Colorado, we do have the advantage of pretty arid environment. But that being said, is there any supporting information to show that with the humidistat, we're actually going to end up with reduced run times than we might actually see if these were on just a regular manual switch?
So I think, again, the big concept here, Eric, is that we just get the fan off versus someone having to go back and turn it off. So, again, it's if you had a humidity control, you're talking $30 to $50. The energy analysis we did was $27 a year in energy savings. So, and it's more expensive. So I don't know that, most likely 90% of the systems that go in are going to have the $15 switch, that go in.
And so just to be clear for everyone, this is proposed within the commercial provisions of the code here in C403, even though there's a little bit of commentary and value associated with this in residential applications. This would be specific to the commercial. So other questions, comments? Does anyone have any concerns about particular language here?
So I guess I have one more comment. Would these controls, because I know typically in like commercial restrooms, you have one switch that turns a light and the fan on in the bathroom. And then the section C405 requires those lightings to be on occupant controls. will this require an additional control so the light and fan will be operated separately, or could they be on the same control?
That's a good question. I suppose that you could make the case either way. If you don't turn the fan on, then you're not, exhausting conditioned air. So, having them separate does make some sense, but I'm not sure currently if they're required to be separate, or are they required, do you know?
No, I mean, I don't think there's any, I think the code just talks about the lighting in the restroom space, but I think
Yeah.
typically they're on the same switch in commercial spaces. And so when they have a switch in the bathroom. So I was just looking at that and seeing if there was any possible conflict, but I'm not really seeing one currently.
Yeah, I would agree.
Mark, go right ahead.
I would say that there's not really a conflict there. It may be that no longer can you do a single switch, but and switch is probably the interesting word there, because like Chuck, you mentioned it's going to be a occupancy sensor that after, and I don't know exactly what the code says on this, but it's a unoccupancy sensor, right? After a certain amount of time, if there's no sensed occupancy, it'll shut off. So that's what the light switch is doing. And as long as that's no greater than 20 minutes, which I can't imagine it is, the code's covered by one device doing both lights and fan. That's a designer's choice to do it that way. So that's on that. And then, I would suggest not including the contaminant control, simply because it is a little bit broad ranged and not well established. And then the reality part of it is that this is going to be, it may be the expensive option, but it's still going to be a cheap contaminant control sensor, whether that's CO2 or whatever. It's not going to be the best one available, and therefore, yeah, I don't think that that's something. It probably fails, running. I don't know that, but I'd be concerned about failure mode of a fancy sensor.
And I'm not married to the contaminant control. It does align with what we're proposing nationally, but
Yeah, so I just found the section in section C405, occupant sensor control functions, which would apply to restrooms and commercial spaces. And it looks like shall automatically turn off lights within 20 minutes after all occupants have left the space. And so item number 2 of this proposal requires the fans to turn off within 30 minutes. So if they were on the same occupancy sensor, there is a 10-minute difference there. So I don't know if, where did the 30 minutes come from? Would it be okay to lower that to 20 minutes? And I agree with Mark Jelinski. I think number 4 can go away because it's just the broadness of it and the lack of specificity would be tough to enforce or regulate.
yeah, I think both of those are fine. So 20 minutes and getting rid of 4.
John, go right ahead.
Yes, sorry, was that for John?
Yes. Yep.
Okay. Yeah. This is just real quick. This is more like kind of nomenclature. In California, they've used the terminology vacancy sensor, so it would automatically shut off, but would require a manual on. I don't know if that's the intent, so it might be good to just clarify if it's kind of a pure automatic on, automatic off, or if it's something else.
So the switch, I've learned a lot about switches after proposing this. So the switch that I installed for $15 has a push button that will turn it on. And the concept, I believe, is, you know, say you're working in your bathroom and you know, you have a bleach spill or something like that. You want to ventilate the space, so you want to leave it on. No different than if you had a switch, and then you have a timer as well. So, so that's why both manual on and one or more of the following controls is that's why it's written that way.
Okay, but in the case that Chuck mentioned with the lighting and fan integrated, would it be able to be just automatic on in that case, or?
Yeah, I guess so you're saying it'd come on when the occupant walks in and then goes off 20 minutes after the occupant leaves?
Yeah, I mean, I'm not suggesting a preference either way. I'm just kind of wanted clarification on that.
I don't see a problem with that. I'm not sure that I can really clarify.
So
I guess the question would be, does it matter if it's a manual on or a automatic on?
right, yeah, in the charging language of the first sentence, it says the exhaust system shall be provided with manual on capability and one or more of the following. So maybe that manual on capability is that, well, I do see the advantage of that. I mean, in the example you used, Mike, I mean, I do see the value of that, you know.
Well,
And
how about
it's separate.
this? How about if number 2 was modified slightly, that said occupancy control that automatically turns on and then off? You know, on when an occupant enters and off when they exit. Because that's what you'd really want. I mean, I think that's what's implied there.
Yeah, but I think there's probably situations where we don't want the fan on. So I think the manual on makes sense as well. You know, we certainly may have a space where you want to go in and flick on the light, or the light comes on a sensor, but you don't need the fan running, right? So I do think that there's an advantage, and that speaks maybe to the earlier conversation regarding separate switching or you know, separate sensors or whatever else for these. So I think, in my opinion, providing the manual on capability is appropriate so that it's intentional to turn the fan on. I mean, obviously people aren't working in the dark, so automatic lights make sense, but not necessarily needing a fan every time.
Agreed. So in effect, what you're saying, Eric, is that you would not have it automatically come on. Does that answer your question, John?
Yeah, I think so. I mean, really, this is just clarification on what's allowed. I know with some of their lighting codes, they have manual on intentionally just to provide a kind of an extra layer of savings. And I'm not even sure whether there's any issue with, you know, either requiring manual on or having it as an option. I'm just kind of wanted to mention it as kind of just clarify so it's clear what's required.
Sure.
Mark Jelinski, go right ahead, please.
Yeah, I'm going to suggest that to keep it flexible, we allow for automatic or manual on capability. An example there is what we were talking about earlier. If indeed it was a designer decided to use a single occupancy switch / sensor to run both of them, that would actually make a lot of sense in many of the applications. You walk in, lights turn on, and the fan turns on. Also, remember what we're talking about here. It's relatively limited. It's probably not a lot of residential, at least not the hotels and such, the single family residents, we're going to be forced to have energy recovery systems, right, for the non-transient type of spaces. So the application is the single seat restroom, that sort of thing, in a smaller commercial occupancy. All I'm suggesting is the opportunity to either have a switch or a occupancy sensor. If we leave it as manual on, then you're pretty much forcing a manual switch right next to manual fan switch right next to the lighting automatic device.
I like that thought, Mark. I like that idea. So that would just simply be editing this portion of the language to say with manual or automatic on capability. Yep. Without a formal vote on that, does anybody have an objection to that idea? That change.
That's fine with me.
So the two things that I've heard in summary are updating the language here to say with manual or automatic on capability, and then deleting item number 4 for contaminant control. Are there any other questions or comments to discuss on this particular item?
Sorry, I may have missed this, but I think also on number 2, it was aligning that with C405, so that would be 20 minutes instead of 30 minutes. Did I get that right?
Yes.
Okay. So that's where is, if I understand correctly, the lighting duration would control, and so they would both shut off after 20.
Yeah.
On that, so for item 2, thank you, Tom. All right. Okay. We're informal, but I'll still ask for general agreement before we move on to the next item. Do we have general agreement that this should be moved forward with the 3 changes that we've just discussed? Head nod or yes or thumbs up or something. Looks generally okay. So feeling like the committee is yes.
I'm sorry. First of all, I had to take care of something here at my home office at the very beginning, and I missed the introductions. I appreciate you asking me to join. Would you clarify? Is my role as a subject matter expert on this, I guess, not necessarily voting member?
Yeah, so sorry, Mark. So for clarification, these supplemental hearings we are intentionally treating a bit less formally than we do our formal code committee hearings, because this is an additional ask for folks that would like to participate. And of course, we really appreciate everybody being here. But we're not following Robert's rules explicitly. We're not asking for a formal vote at the end of each one. We're trying to agree upon consensus with some minor tweaks as we've just done for this one, and then move forward. So in terms of in your role, Mark, yeah, subject matter expert, there really isn't any voting, unless we get to a point where it feels like we're split on something. Maybe I'll call for a formal vote, but in this, it seems like there's general agreement across the majority of the group there, so I'm not concerned. Yep.
One other comment. So originally when this was proposed, it was proposed to be in the residential. What was the concept? We screwed that up and didn't actually go apply it to the residential. So, in my opinion, there's a lot of energy to be saved on the residential side, especially as you electrify. So, I realize this doesn't have a residential focus on it, but it is something that, to me makes a lot of sense to apply to that. And if you did, I would suggest adding showers to this as well.
So are you saying, Mike, that there was not a counterpart residential proposal to accompany this with similar language?
Correct.
And with respect to residential, we'd be talking about single family and duplex and,
Correct.
maybe a few townhomes, that sort of thing as well.
Correct. Yeah.
Hmm.
For new construction.
Yeah, I certainly hear you. Now, when you mentioned something about the showers, are you referring to the humidistat component of this, or what are you referring to when you say apply to showers?
Yeah, so at the national level, we fixed it, and we're going for both the residential and the commercial codes. So the humidity control and the contaminant control really are addressed in the residential. It's applied specifically for the residential side. So it would be less applicable here than in the commercial side, obviously.
Mm-hmm. Right. Can you speak a little bit more to the contaminant control on the residential side? It seems like that would actually maybe be regulated by other codes or standards.
So on the contaminant control, that was something, like I said, we've been working with Brown on the national proposal, and that was something that they were pretty passionate about. So I could bring them on if you wanted to talk about this specifically on the residential side.
Let's see. I mean, I do, personally, I certainly see the impact in the value of some of these on the residential side. I feel like there could potentially also be a bit more objection because people prefer to have control over their own home and, airflow and things like that a little bit more. And that makes me a little hesitant to try to put something like that in without greater committee involvement. So that being said, what we could do is if you have that proposal prepared, we could consider taking it to the full committee, the IECC committee, which we will be, bringing back online most likely in July. And we could go down that road, but I wouldn't think it would be appropriate for this group simply to add all of those requirements for residential at this level. That's
okay.
That's
fine. I just wanted to bring it up that I think there's a bigger bang for the buck for the city residentially.
I hear you, and I agree. Nathan, you had your hand up. Go right ahead.
Oh, I was just gonna comment from a residential standpoint on this. I just in conversations with our builder clients, the lighting control issue that's coming into the 2021 residential provisions is one of the focus points that a lot of the builders are having, and it's a big deal to a lot of them. That I think the pricing they're seeing is way more than $15 for a timer or an occupancy sensor. So that's the one piece that would concern me about residential. But in the past, I've worked with both Brown and Panasonic on some of their sensing products. And if it is an option, I think it's great from an energy saving standpoint to be able to sense and ventilate actually less than a specific time or volume would require under the current code. So if it's an option, I'd say bring it in, but just know that there's going to be objection from builders.
Thank you. Chuck, go ahead.
And to kind of add to what you just mentioned, Eric, looking in the lighting controls in 2021, the residential portion, there are lighting controls required at all permanent fixtures in a residence, except lighting controls are not required in bathrooms. So I think that's an interesting caveat that the residential specifically does not require the lighting controls, and then this would add mandatory fan controls to be added in the one space that's not required to have lighting controls. Not that it's a bad idea, just it's
Yeah.
we aligned those in the commercial with the 20 minutes to 30 minutes, and then doing it in the residential, they should be aligned. So if we were going to do that, I think the lighting controls would need to be also considered.
Maybe.
I think you have safety considerations in bathrooms. When people are in showers, you can't have the lights turning off.
Yep. You're behind
Even
a curtain.
if you're not in showers, I know that I've been in the web building and the lights have gone off in the bathroom, and that just tells me that I need to go home because it's so damn late that the lights are automatically shutting off. But we'll go from there. So Mike, yeah, let's if you've got that proposal ready, so you can certainly email it into the city folks here, and we can look at maybe putting it on a formal committee agenda down the road.
Okay.
All right. Otherwise, I feel like we're in pretty good shape on this one as it exists. Is everybody okay if we move on to the next item? All right, I'm seeing head nods. That. Welcome,
All right.
Elizabeth. Nice to see you.
Yeah, hey, sorry I'm late. Had overlapping meetings.
Okay, so whoops, apologies. Give me just a second here. Okay, the next proposal is number 95. This is a Green Code Energy specific Chapter 7 HVAC efficiencies, and I'll open this up, and then John, I'll give you an opportunity to speak through the revisions here.
Okay, great. Yeah, so thanks. So as I mentioned, this is a green code proposal, so it's a voluntary, within the voluntary green code. And the intent here is to really promote good practice. As many of you know, there are federal minimum efficiency regulations for a lot of HVAC equipment, and energy codes through preemption are prohibited from specifying more efficient products. Some jurisdictions have actually tried and failed, and that's not what I'm proposing to do, since this is the green code. But what the thought was here was to really kind of focus on a few common equipment types, kind of picking on smaller buildings because chillers are another kind of ball game. But looking at the air conditioning and condensing units for packaged equipment, either small packaged equipment, larger unitary or packaged air conditioners, as well as packaged smaller packaged equipment and heat pumps. So what we have here are some requirements for minimum requirements proposed for, again, for the green code that would require, the first bullet, table A, requires air conditioners with a rated capacity between 65 and 135 kBTUs. So that's roughly between 5 and, gosh, I'm doing my math wrong in my head, about 15 tons or so, would have a minimum rated EER as well as IEER. So at the risk of kind of mentioning this to people that may know this already, so the EER is your full load efficiency rating that's given by a manufacturer, and the IEER, or integrated energy efficiency ratio, is meant to be kind of an aggregate or a composite or annual reading, and both of these are provided by the equipment. So the proposal is to try to increase these beyond the minimum requirements for green code buildings. And I have a similar requirement for, actually, yeah, this is, so for even larger equipment, I think this should say, might need to check the capacity ranges on these. But with the larger equipment, we would have and also an increased EER ratio of 12.2 and an IEER of 15.8. For larger equipment, yeah, so we have again a higher EER rating here and a minimum part load rating of 18.6. And then for package equipment smaller than 65 kBTU, so these are the very small light commercial units, 3, 4, 5 ton units, shall have a minimum SEER2 rating of 16.5 and a minimum full load rating where applicable of 13. And there's also a recommendation for a minimum efficiency rating for small packaged heat pumps. Now, AHRI has been changing the performance ratings from SEER to SEER2. So this will, there has to be a slight translation in the performance requirements. And so how are these requirements set? So what I did was I looked at the available products in the AHRI database for these equipment classes, and I was looking simply statistically what was available for different performance ranges. And if you look at equipment performance around the 75th to 80th percentile, that means about 20% or more of qualifying products would have higher efficiency than these, that about 20% of these products would qualify for this proposed requirement. So one question some might ask, well, this sounds great, but why not just make it an option? Why not give more flexibility? And certainly that is important, especially in the base code. But for the green code, the idea is if we can promote higher efficiency equipment that is available today, that it would increase circulation or penetration of that type of equipment and would help drive down costs for these equipment. I don't include cost data on this proposal. There is certainly would be a slight cost increase for some of this equipment. But the idea is to help incentivize this type of equipment, really because the base code does a pretty good job overall. If you think about economizers, we have heat recovery, demand control, ventilation, et cetera, and so on, fault detection. Most of the requirements that are already part of good practice are already required by the base code. So there's on the HVAC for some of these smaller buildings, there's limited opportunities to exceed the base code. So the idea here is to incentivize it with specific targeted requirements. And as a side note, we've worked kind of indirectly with some of the people on the ASHRAE committees for SBC 205, which is trying to develop more robust performance models for energy simulations for these equipment, because certainly having 1 or 2 rating points, one of which is a composite point, isn't sufficient to characterize the performance of a particular equipment in a model. And they're making improvements and working towards improving that, but those improved, more robust data maps are not yet available. So the idea here is to really kind of help push or drive the market a little bit to say that these, these equipment are available today and are good performance and can be specified. So with that, I'll take any comments, questions.
Thoughts from the group, comments, questions? I'll give it another.
Maybe I'll
less.
Eric, maybe I'll just throw the question out there because I know this this is kind of targeting some specific equipment classes and adding new requirements. And even though it's the green code, yeah, I would like to hear thoughts on, in general, this approach of kind of pushing requirements for specific equipment or measures in the green code versus adding, more flexibility. Certainly, the green code, if we have an energy credit system, we can add credit points and add requirements there. But the idea here is to really drive the equipment efficiency kind of beyond the minimum, because it's in my experience, it's often the case, even with relatively high performing projects, a lot of projects will use the minimum available minimum efficiency equipment more or less for these types of systems.
So John, I have a question for you. So your categories here, these three, I guess, ABC categories here, those are intended to sort of align with efficiency tables in the IECC, and part of what I'm looking at or curious about is C in particular, where you're just referring to packaged unitary equipment. Is that intended to be literally just packaged unitary equipment at that capacity, or are you intending to encompass a non-packaged split system as well?
This would be just packaged equipment. So certainly, yeah, for our earlier conversation on these, that there are a lot of small buildings that may have split systems instead of that capacity size, splits or mini splits. This was intended really just for the packaged equipment. So it's really trying to, I might need to double check these categories here, the size ranges, but the idea was that there's a C is actually the smallest capacity range. Then the A and B would have the couple different size ranges for larger package units, say between 65 kBTU and 240 kBTU. So 240, that upper range corresponds to about 20 tons nominal capacity, which covers a good portion of small and medium commercial buildings that use this type of equipment. So, and also just to kind of, maybe obvious, but just to emphasize, so, systems that don't fall neatly within these tables, so like a VRF, I'm not really addressing here, or a water source heat pump. There are classes of equipment not addressing specifically in this proposal, but really trying to raise the bar, I guess, on the green code for these types of equipment.
And would you, I'm thinking based on what you're saying, you're not intending to include like P-tax and V-tax in that. Would you specifically exclude those? Because I look at a P-tax and a V-tax, and I know that that's a separate category in separate tables in the IECC, but they are still packaged unitary equipment. Are you intending to include those in here, or not?
I hadn't intended to. If there's sufficient interest from the group, we could include those, certainly. I haven't looked to see what the range of efficiencies are available for those type of.
And I say that because there aren't any.
they're often quite well, relatively inefficient, especially the P-tax. And the single package vertical heat pumps put on relocatable classrooms and whatnot, they're also pretty inefficient. Part of the reason for looking at these equipment types was that there is a pretty good spread of performance available, on these systems. So if you look at what I would propose here, I would loosely call good performance, or maybe even best practice, but it's not the highest available efficiency today for these equipment. And certainly the mini splits can get very high efficiency. I haven't really looked at that here.
So in your point, let's see, the IECC table, let's see, what is it, 403.3.21. So we're really only trying to hit that table. That's right?
Yeah, let me bring that up so I can confirm that on my side. Let's see.
Because that table does also get into some water cooled stuff, but I think you're really just referring to air cooled in all these sections, right?
Right. So
Except for C, you don't actually specifically say air cooled for C.
right. So the intent here was also air cooled. Yeah, that's right.
So that would need to be added for C. You've got it in A and B. But that 403.3.21 does include water cooled and evaporatively cooled.
Right. So I might need to clarify that these only would impact specific types of equipment within those tables. That's right.
Would we want to include the evaporative cooling systems since this is green code and given the the water usage associated with that, the kind of opportunity cost?
I can address that in a couple other things here.
Go ahead, Mark.
Yeah, first of all, it is the green code, so certain things are, we can certainly push the envelope on this. In general, I understand where a lot of the research was done here. It makes an awful lot of sense that the research was done here to determine that, yeah, there's equipment in the 20% range that's available within these categories that you did the research on. Elizabeth pointed out that, yeah, PTACs are a whole nother thing altogether. And if those are, one point to think about is that something for the grain code in the first place? But in the context of what this is trying to do, it's trying to push the envelope on specific types of equipment. My research was that, yeah, there is that equipment because obviously the AHRI directory addresses that. The individual manufacturers have told me that they themselves don't necessarily have that full range everywhere, and it will make packaging of jobs and putting together a consistent package might be a little bit interesting if you're trying to meet the green code, right? It's supposed to be a push code, so that might not be a huge objection that it's hard to pull together the type of equipment that's needed here. I don't want that to be the objection. I just want it to be noted. And then I think, Elizabeth, you worked really well through the ideas of what's shown in the tables of the base code, table 403.3.2. All the numbers that follow. We need to use those words because, first of all, it's addressed in the base code, but more importantly, it's addressed by AHRI's testing standards and rating standards. And all the equipment that you're talking about here is intended, I can see, to be AHRI equipment. Elizabeth, you asked about, does it really mean package? There's, I get into, and actually Mike gets into a lot of custom equipment. And when we start talking custom equipment, we're definitely coloring outside the lines. We're still obligated to meet in the base code. It's more interesting in the green code, but in the base code, we're still obligated to meet those minimum IERs and EERs, even with custom equipment. The interesting thing is it's just not quote unquote certified. I believe that the intent here is to stay within the lines of certified AHRI equipment, which essentially by definition means package. There's a catalog to it. Great, I encourage that. And about the only other thing I would do here is just what you already pointed out, Elizabeth. Let's limit that to air-cooled equipment for now. And then to address, somebody asked about evaporative cooled. This isn't really evaporative in this context. It's not evaporative cooling, you know, quote unquote swamp coolers. This is simply a packaged unit that sprays water on the condensing coil to take advantage of local conditions and you know, wet bulb versus dry bulb condensing temperatures. I don't think that would be the intent for this measure, which is trying to push the limit on this simple packaged equipment. So I would leave the evaporative cooled out of it, but define C as including air cooled only.
Yeah, I think that's the correct, and I'm not as familiar with evaporative equipment. I know there's smaller units like the Frias where they do just that. They spray the condenser. And I know there's other technologies entirely like you know, direct and indirect evaporative cooling, either on the air side or condenser side. That's probably beyond the scope here. And yeah, I would agree. And just to reiterate, so this isn't intended to push the market a bit and push the envelope for these types of equipment using standardized ratings and standard off-the-shelf products. I know with the major manufacturers, part of the reasons, you know, the equipment may have a you know, order magnitude 10%, 15%, maybe 20% premium for equipment price only. It could be simply due to the fact that they just don't have the same line capacity, so they don't have the same economies of scale. There's some other parts required. But I do also know that a lot of the recent gains, especially on the smaller systems, has been due to controls and been able to control the compressor staging better using inverters, digital scroll, other technologies, and that's where that it won't help you too much on the peak demands, but the part load ratings, the IEER and the SEER, really have come up for some of the high performing equipment. And that's the idea, is to you know, to specify these things.
I think we just need to get a little clarification or maybe reconciliation between how the categories and the subcategories in table 403.3.21 read relative to this. So like there's I'd say three main columns. You've got the equipment type, you've got the size category, and then you've got the subcategory. And the subcategory refers to single package, split systems, that kind of thing. So I think you'd have to clarify, are these intended to apply to all those subcategories, or are you only intending to apply them to the single package subcategory, if you follow me there? I'd also say the same thing for the column that refers to equipment type. There's air conditioners, air cooled, I think is what you're intending here, but there's also space constrained air cooled, small duct, high velocity air cooled, and then it gets into the water cooled stuff. So if we could just make these words align with that table so that it's really clear which ones are the minimum efficiencies that we're attempting to apply to. Did you follow me there?
I did. Yeah, that's a good point. Maybe it would make sense if it's, I don't know if it makes sense structurally as far as code language within the green code, but just to have a copy of those tables with the modifications.
Yeah, that's a great idea. I think that would make it really obvious what you're attempting to edit.
Yeah.
Because it's not totally clear to me right now.
Right.
Chuck, go ahead.
No, Elizabeth covered exactly what I was going to suggest, is that it looks like from the charging language in the top paragraph is that these shall supersede the performance requirements of tables 403, 1 and 2. And so I was going to suggest let's put this in table form to replace those specific sections, so it's real clear which items are being superseded. And just that'll help clarify some of the confusion with that number A, where you have the 403.3.21 in parentheses. It's kind of where the other two don't have a table referenced, so it would help clarify the intent.
Yep, definitely.
Right.
All right, so John, it sounds like a bit of formatting in addition to clarification with respect to the coordination with model code language. And maybe the final proposal has a bit of a different format with the tables being added. That being said, let me step back for a second and ask the entire group if generally we feel good and comfortable about moving this language forward with some of the edits that we've been discussing. Thanks, Nathan. So I saw one head nod, and I can also ask the opposite question. Does anybody have any additional questions or concerns or objections to moving this forward in the green code? So I think we do have at least some general consensus to move this forward. John, I've got some notes. I'm sure you do as well. I'll ask you to make those revisions and then send them back in to us here so that we have a final draft.
Okay, great.
Okay, excellent. All right. Moving then, we will to the next item, proposal 77.2. This is also green code, and this is for waste heat recapture. I will turn it back to you, John.
Great. So this is again a green code proposal. So it's not for the base code. This is a measure that's been considered in other jurisdictions, and the one of the reasons it's considered for the green code is the cost benefit is kind of marginal. It can be cost effective, but it kind of depends on the use and installation costs. But the idea here is to require a form of drain water heat recovery on all commercial buildings and R2 occupancies on shower facilities specifically. So these are installed on typically on non-residential buildings that have or are required to have be installed where there's 4 or more showers on a shared drain line. So there's a couple, there's at least 2 or 3 different configurations of this type of heat recovery that can be done. You could have one device on each drain line. You could have a distributed system serving multiple floors, or there's central systems or systems gang together on a single manifold. Or you can have devices, as I mentioned, serving individual shower drains. The drain water heat recovery itself it's a passive device, so it's just recovering heat from the wastewater from the shower the shower point of use as it's being used. There's another comment at the end of the first paragraph. There's some systems that are more maybe elegant or robust for using heat recovery from wastewater on the heat rejection of the condenser systems. There's one manufacturer in particular that makes a heat pump water heater that uses wastewater for heat rejection. So although that's a different type of system, that one is considered to meet all of the requirements of this system. Some of these other requirements follow plumbing code requirements as far as having proper drainage, quarter inch per linear foot. There's also a requirement added here for installing heat recovery on laundry systems that include 4 or more laundry washing machines. These systems can be either vertical or horizontal in nature. I think the majority of them are vertical in nature due to ease of design and installation. Let's see. That's the overall summary of this. If you scroll down a little bit, let me see if there's. Yeah, I guess that's about it. And you know, there can be a little bit more of a design challenge installing systems on the ground floor for proper drainage, but that's the essential requirement here for the green code. Are there any comments, questions on that? Please unmute.
Mark, yep, go right ahead.
Yeah, hi. So is it the intent? First of all, again, recognize it's the green code, so that's cool. Is it the intent to do something more than the type of drain water heat recovery units that are really simply just the copper tubing wrapped around a length of pipe? Is that the intent? Do you want to do something more than that?
No, not necessarily, no. So that is the intent. They're basically just a you know, standard kind of counterflow heat exchanger passive device. There is well, I guess I can mention the name. There's other types of systems that are kind of different things entirely. Piranha is one of the models of a heat pump water heater that has that basically uses the wastewater for heat rejection. Now that's a completely different type of system. You know, it's but it's something that's considered to sort of be in the same space or have some of the same overlap for some of the intents to reuse the wastewater. So that one's considered to meet the intent, but that would be either or. So it really is just the passive. The minimum requirement here would be the passive recovery heat device.
That last bit was important. So, because these are, they're apples and you know, rocks. They're completely different things. One is just a piece of pipe wrapped around another piece of pipe. The other is a complete system that requires a lot of engineering. You know, that's what's being done down at the stock show complex, of course. So what I would suggest is that this is a good thing for the green code. These things are really pretty effective where applied appropriately. I would recommend that this stick with just the drain pipe heat recovery system. Now, how you could introduce wastewater heat recovery, heat pump heat recovery, is perhaps make an exception. You would still meet the green code if you've done a wastewater heat recovery, centralized wastewater heat recovery system. And that is very difficult to try to explain and to write into a code. I'm not sure that that's practical other than as a exclusion or an exception to this otherwise requirement. The other item I would say, even within the green code, the only way these things really make sense is if you're not having to add a whole lot more piping to the system. Where these things make sense is in particular showers. Showers are wonderful because a shower already has a cold inlet and a hot inlet. And what you do is you take the regular domestic hot water to the hot inlet and you run the cold water through the looped pipe around the drain and then into the cold inlet, so that the cold water, you know, you don't need as much hot water because the cold water's doing the thing. Now, that also requires a thermostatic shower valve, because otherwise the temperatures get all out of whack when sometimes the water is cold and sometimes the water is hot. This is why it does belong in the green code, because it gets interesting to actually apply it. It works well on gang showers because you got a whole lot of bang for the buck, a lot of drains, and one master valve that you have to take it back to. What gets really tough and cost inefficient is when you're adding a bunch of pipe just to get a recirc line back through and recirc's the wrong pipe, by the way, because you're usually keeping your recirc at like 110 degrees or so. It's just water that's not being used by the fixture. So if you were to take that back through the drain heat exchanger, you'd end up heating your drain line. You don't want to do that. The only way these things work is to take cold water through the drain line and then take it into what would have been cold makeup to something like a domestic shower valve. Another place it can go to is a small little water heater within, again, 10 or 15 feet. But you start going much more 20, 30, 100 feet, and you're buying a lot of copper. So is what I said able to be put into a code?
Yeah, I would raise it to the group as far as how to handle the more central systems that are like I mentioned here in this earlier in this document where it shows the actually we could scroll up just a little. There it is. Yeah, thank you. I just want to get the exact language. So I say central heat pump water heaters that use wastewater for heat rejection shall also meet the requirements of this section. Should that be made as more as an exception or structured differently, worded differently, removed? The other thought I had, which I discussed, I think briefly with someone at Denver, was to if you really wanted to push it, you could lower the threshold at which heat recovery is required from central hot water systems, but that these systems they're central, but they're fairly small capacity, so that may not make sense to make those a requirement in all of those cases. So as was mentioned, we want to require either apples or rocks or apples or pineapple, but is this current language sufficient? Is there a better way to structure it? Chuck?
Structurally, I find this section tough to read, to know when it's required and when it's not required. Because it starts off as drain water heat recovery is installed in all commercial buildings and all IBC R2 occupancies on shower facilities. So first, in that first sentence, the shower facilities apply just to R2 or commercial buildings, and what's the definition of a shower facility? So the next sentence says, on non-residential buildings that have 4 or more showers on a shared drain line. So now we've gone from commercial and R2 occupancies to now a non-residential building. So it's like a third word or term of jargon being thrown in here. And 4 or more showers on a shared drain line. Well, most buildings have one building sewer leaving the building. So that sentence essentially means to me that if there's more than 4 showers anywhere in the entire building, the drain heat recovery is going to be required. And so I don't know if the intent is if there's, a shared, a gang shower with 4 or more heads, like a rec center or something like that, or is it intended for R2 when there's 4 units or units with a total of 4 showers provided. Then moving on, it starts trying to talk about the different systems that would be allowed. So distributed systems on multiple floors, gang systems connected to a single or manifold heat recovery device. Individual shower drains can be provided with a heat recovery. central systems for buildings with R2 occupancies and central waters shall meet this section. So it seems to clarify central systems only for R2 occupancies. Would the other non-residential applications be okay with a central water heating system to meet the requirements of this section? And the central heat pump water heaters that use wastewater for heat rejection, isn't the wastewater at that point the heat source for the heat pump water heater, not rejecting heat to the wastewater? Then continuing down, there's all domestic heat recovery systems shall meet the UPC requirements. That should be the IPC requirements. Is UPC is California. Then there's a new requirement when drain heat recovery is required that's introduced here, where the R2 has 4 or more laundry washing machines. And I guess my question would be, why are we limiting the 4 or more laundry washing machines to just R2? Like if there's a commercial laundry, like a coin-op laundry, would there be opportunity for heat recovery to be applied there? Then continuing down, there's 2 references to Iatmo, and currently the Iatmo is more of a U-code standard and listing agency, and so I didn't know is there not a complementary I-code standard that could be referenced, and is the Iatmo standard needed to be referenced in these applications? Then the item B there references the 2018 IPC. It should be the 2021 IPC, because we'll be adopting this at that time. And so I think there's an opportunity. There's a couple references to the IPC here, and I think we could just leave it very broad, but also specific, saying that any heat recovery system would need to meet IPC, because there's multiple items that are going to need to be considered when complying with the IPC. Obviously, the heat recovery, heat exchanger, maintaining potable water, the drainage slope will need to be considered, and then we can't restrict the flow of the water as well, or the drain water as well. We can't create any things that can be clogged. And then in the base code of the IECC, there's a requirement for residential heat recovery units to meet CSA B55.1. And I didn't see it referenced here, so I didn't know if that was needed to be referenced here, or is it, since it's in base code, it's already implied? And then there's a 10 PSI limit for the potable water supply for pressure loss across a heat recovery system in the I code, in the IECC. So I didn't know if we needed, is 10 PSI the right pressure drop allowed for the potable or for the cold water in the green code, or since it's already in the IECC, is it okay to be where it's at? Those are my thoughts. Sorry if I rambled.
No, those were a lot of good thoughts and more comments. And first, yeah, on the formatting and the requirements, I should clarify the intended applicability of this, where it applies to residential occupancies, where commercial occupancies. So I'll have to do some cleanup to that. As far as the IPC, I can update those references, and we can certainly keep it broad to cover, make sure that it complies with the requirements in IPC in general, but I can also look to see if there's specific analog to some of the Iatmo requirement that's mentioned here. As far as the pressure drop, I'll have to double check that as well. I think probably the IECC requirement would be fine, but I don't know off the top of my head if there's any issue with the 10 psi limit.
Looks like Chuck's camera may have frozen up on him there, but so we've got some good notes on that. John, I had one other question. This is specified for, in some instances, group R2 occupancy. So, you know, for apartment buildings where we have probably a more consistent occupancy. Was it intentional to exclude R1 occupancies, which are, you know, hotels, from this just due to the inconsistency of occupancy, or was that, did you have a different thought about that?
I'm not sure. I think there is some potential there for the R1 occupancy. I think one, I'm not a designer of these, but one thing I understand with the hotels is that generally the floor-to-floor heights is a little bit lower. So I don't know whether there would be any additional space constraints for the piping. Otherwise, I don't recall if there's any particular reason why we excluded those.
Yeah, that was part of your, I think, justification, an underlined section down here in supporting that the floor-to-floor height is a design consideration. All right, I think Chuck's back with his hand up. Maybe Chuck, are you there? Can you hear us?
All right, so a few more thoughts that just you help me remind me of. One, I'm not sure hotel is excluded because we have all non-residential or commercial buildings, and I would say that that sort of covers it. So I think we really need to define applicability. If we're intending to drop hotels off, we really need to work on the language for applicability. And then thoughts on hotels. I mean, they are almost exclusively central hot water systems. So I think there's a huge opportunity to use heat recovery in a hotel. So I think that's a system where apartment buildings typically are designed with individual water heaters in the unit. So you'd almost have to either intentionally gang it together and have a central hot water system, or you'd have to have the additional cost per unit to have a heat recovery device in an apartment. So I think hotels is a bigger opportunity. And then I know in the Title 24, there's an exception for single-story buildings. Essentially, trying to install these heat recovery devices in the slab is a challenge. And so I didn't know if we should be considering a similar exception, or if this is the green code and intend on design teams to get creative.
Yeah, I think the single story is probably a good place for exception here, actually, given some of the design challenges for installation.
I also had just an implementation question about, how much of the hot water system is, or how much of the drain system has to have heat recovery. Like if I have it on just on my showers and not my laundry, or, just on some showers, but not all, like, maybe it's the floors 2 and 3, but not floor 1 or something like that. Does that need to be explicitly defined? And maybe it doesn't if that's already in some of these other standards, but I'm not familiar with those. Like, is there a percentage of the drain water that has to be recovered?
Yeah, so that's a good question. I think the idea was that the showers would be the minimum. I'll need to be more precise and explicit on the requirements for the laundry, I think. And then I think for a building, multi-story building that has showers on the first floor, I think there could be a consideration for excluding those. I know there's an energy credit considered by another organization that was developed the energy credits, where they were looking at exempting first floor showers from the requirement. So we could do it as a first floor exemption or as a percentage, perhaps. Any thoughts from the rest of the group on those comments? Or
a lot of good information here, and it seems like there's definitely some work to be done in terms of clarification, revisions, intent, applicability section, reference updates, and so I'll have two comments, I suppose, or one comment and one question. My comment is that I feel like we need to work on the edits and then potentially come back to maybe this group, the supplemental team, to maybe to hear this in an improved format. So that's one direction that we can go. The other one is, we can ask John to make these edits, and then, the city staff can take responsibility for reviewing, what we've talked about, taking pretty extensive notes on our conversation, and we can do that as well. And then the third option is if generally we disagree that this is an option that should be in the green code, then that's not something that we would choose to pursue. I feel like that's probably not the case, but it is part of our discussion. So interested to hear a little bit of feedback from other experts and interested parties in terms of what you would be comfortable with from the best approach for this particular proposal.
Personally, I think.
Go ahead, Chuck.
I'll jump in. I think I think this is a good proposal, and so we should consider it for the green code to start getting designers and teams to start looking at heat recovery for water systems, and maybe the cost will come down on them and they'll actually become more viable. And especially as we electrify, heat pump water heaters don't have the recovery rate, and so being able to recover heat from the systems will help the electrification piece as well moving forward. So I think bringing it back to this group to discuss, because there is, just the applicability, and there's just a lot here. It would be good to have a group of eyes on it. Personally, my vote.
I'm seeing a couple other head nods there. I feel like that's a good way to go. So I'm going to ask for consensus from this team, if we can ask John to do some edits, and then come back to the supplemental committee for a cleaned up version of this. Does that sound okay? Can I get some head nods or thumbs up or something like that? Yep. Okay. Yep. I feel like that's the way to go. Definitely the majority of folks there. So that'll be the charge for this one, John. And we will look for the next time we convene on this one. Any other final thoughts or comments on this particular proposal before we move on? Not hearing any. Let me go back to the agenda. I will observe that we've worked through 3 of these, the top 3 here out of the 8 that we have. It's taking about 30 minutes to get through each one, and we only have about 30 minutes left in the conversation today. If there is a preference by anyone on the committee to speak to any of these out of order, feel free to speak up. If there's not a preference, we'll just move on to the very next one, which is registrations. if anyone would like to tackle one of the other ones in today's discussion, I certainly don't have any objection to skipping around a little bit if we want to. So I'll open up the floor there for a minute. If there's no preference, then let's move on to the next one.
We're going to make sure we get to all of them regardless. Is that true?
Yes, we will. There will be at least one additional supplemental hearing like this outside of the formal committee. Potentially another, but at least one more. Mark, go ahead.
Yeah, I was going to suggest that the one on economizers is going to be one of the more difficult ones or time-consuming ones potentially. So, do we want to address that now? Especially, maybe we can address that now, and it'll require going back and coming back with an improved version. That'd be my comment. That's what I'd like to. That's on my radar is the economizers one.
All right, so we've got one opinion or vote to jump down to economizer number 57, C403.5. Any other thoughts, questions, objections? If not, I'm happy to jump over that one. All right, economizers it is. So this will likely be the last one that we can speak around today, and that's fine. As I mentioned, we'll come back to others at a later time. But for today, let's dive into economizers.
Okay, great. Thanks. So this is one that was presented briefly earlier, and there were some modifications made. Just to kind of recap, so the intent here essentially was to lower the threshold at which airside economizers are required from 54 kBtu to 33 kBtu. So that would effectively cover systems as low as 3 tons nominal capacity. So that was the change here. This also aligns with some of the fault detection requirements that there are already present in the code. Now, there are a number of exceptions here, and there was a little bit of rework done on the exceptions. Most of these exceptions, 1 and 3 through 6, were kept as is. So I'll just go through these quickly. Where more than 25% of the air is designed to be provided to spaces that are to be humidified above 35-degree dew point temperature to satisfy process needs. So 35 that's relatively low dew point, but systems scheduled to operate less than 20 hours a week. That's not going to affect most of the buildings that we're looking at. System serving supermarket areas with open refrigerated casework. A lot of times those systems in that area have different, slightly different requirements. Sometimes they have hot gas reheat so that they can keep the air dehumidified below a specific set dew point temperature. Number 5. Cooling efficiency greater. This is, and by the way, most of these are, I think these are all existing requirements to the current IECC code. So the cooling efficiency is greater than or equal to this efficiency requirements. The higher efficiency, it's a trade-off basically between efficiency and economizer. Systems that use heat recovery. Now number 7, 7 and 8 are the ones to focus on. The 7 I thought of removing, but I ended up keeping it in, and I can explain why. If the BRF systems installed with a dedicated outdoor air system, so they have a separate supply of outside air. So they're typically, those systems are, for BRF, are only going to provide heating and cooling. So it wouldn't make sense to have an economizer in that case. If we were to not keep that exception, then those projects would have to use the performance approach. It seems like a reasonable exception. And then for number 8, we kind of went back and forth on the language a bit. But I think because it's defined elsewhere in the code, using the term split systems. So split systems with cooling capacity less than 54,000 BTUs per hour that don't provide a supply of outside air ventilation. So it could be a split system, could be could be other types of compact systems where there's a separate outside air source. And then for integrated economizer control, what I've done here, oh yeah, so the rooftop units with capacity at least 33,000 BTUs per hour. Sure what it says, less than, shall have an economizer with 2 stages of capacity. So first stage controlling the economizer and second stage controlling mechanical cooling. For units with integrated economizer control, there's some requirements that these are kind of carried over from ASHRAE 90.1 2019 in the indented text, starting with economizer systems. So I've kept these requirements as is, and then I've added, I'm not sure the perfectly appropriate way to do this within the IECC as far as referencing a table, but for this purpose, I've just duplicated the table that shows cooling stage requirements for modulating airflow. So if there's units of a certain capacity, they require between 65 and 240 kBTUs. It requires 3 cooling stages with a certain amount of minimum unloading of the compressor from full load. So that essentially is the proposal. So the couple changes would be from the previous version were to clarify some of the exceptions given to this, and then to kind of clean up the language here for referencing staging and other requirements from ASHRAE 90.1. Again, this is from ASHRAE 90.1 2019. And then I'll go through the rationale for those that may not have heard the earlier iteration of this. The idea here is to certainly improve efficiency and reduce energy use of the systems on smaller capacity systems by requiring those economizers to minimize operation of the compressor when free cooling is available. So, and by lowering the capacity threshold down to 33 kBTU, this would impact especially a lot of small, mid-size, often low-rise commercial buildings that might have 3-4 ton units. Even some big box retail will use these units when they want control of a single zone. So it reduces energy use, improves performance, and yeah, basically the requirements similar to an IGCC proposal, and that the systems are widely available. It's a readily available technology. It's been used on buildings with lowest capacities as shown here that I've seen, at least on retail buildings in my commissioning testing. And yeah, that's the proposal. So I'll take comments, questions, concerns.
Yeah, I have a question, John, on your exception 8 there, as it has to do with split systems.
Mhm.
When we talked about this last time, I don't think we were trying to exclude systems that do provide, let me back up. Can you explain the sentence or the second half of that statement where it says that do not provide a supply of outside air ventilation? Because I'm picturing like, you know, little tiny office buildings that have like a furnace and a split AC unit. They would provide a supply of outside air ventilation, but that is a more efficient system than a rooftop unit. So I would not want to require that system to go to an economizer.
Okay. May need to clarify that exactly when this is required. Like I know, for example, there are some systems that will, even these single package vertical air conditioners, I believe, may not have a ventilation supply, but if they do, then they'll be bringing in outside air ventilation. May need to look closely at the full range of some of these systems you're referring to. I mean, I understand what you're mentioning it. I'm not seeing that as very common, but we want to make sure that we handle all of these appropriately. The one that I definitely want to, well, I can to back up. The one that I'm trying to make sure that it is properly excluded is a typical split system where you have a remote condensing unit and then you have an indoor unit. That should not be required to have an economizer. So
I think I am too, but that system would still be required to have a supply of outside air ventilation. So I think if these may be two different things, I mean, if there may be split systems that are less than 54,000 BTUH, period, and then there may be systems that do not provide a supply of outside air ventilation, but those would still have to have a separate air handler that provides the supply of outside air ventilation. And that system, I don't know, I guess you could decide if that system needs to have an economizer mode or not. But there may be two different things here. But the system you just described where you have an interior air handler, that system still has to have supply outside air. I mean, that's code. Unless it's got a dedicated outside air system, but that would be a separate animal.
There's a hand up, I believe. Maybe another question or clarification.
Yeah, go ahead, Mark.
Yeah, a couple things on this. This exception 8 in particular, in the context of what we're trying to do here, which is increase the efficiency required under the Denver codes and the energy code. This is reducing that. Right now, today, if we have a split system greater than 54,000 MBH, we got to put in an economizer. That's a good thing. It keeps me from requiring a building to spin a compressor all year long to cool a space. And there's plenty of places where we do this without outside air ventilation. One of the classic places to do a split system is for interior equipment cooling. I would do it with a split system, but you know what? I shouldn't be allowed to start putting 4.5, 5 ton, 100 ton. There's no limitation here. Split systems without an economizer. I should be required to provide an economizer once we get above 54,000 BTUs. That's always been in the code, and this would be a lessening of the code.
You still have the 54,000 cutoff there. That I don't think exception 8 would allow you to have 100,000 BTUH system without an economizer.
Less than, why did I first of all apologize for taking that time. It does say with less than 54,000 BTUs H. So I guess I'm missing the point then, because where was it? Aren't we already limited to individual fan cooling units less than 54,000?
The whole proposal is changing the 54,000 to 33,000. So my point is that split systems between 33 and
Oh, there we go.
54,000 BTUH are,
Yep.
and if I've got a little tiny fan coil or a furnace or something that I can operate at 0.2 or 0.3 watts per CFM, that as a system in its entirety is more energy efficient than a rooftop unit with an economizer.
I'll get into that in a second, but I apologize. I did misunderstand this. This is allowing for that 4-ton IT room split system without an economizer, and that's cool. That's no worse than what the code is requiring now. Anyway, I misread that. Let me talk about the other issue, which was where economizers should be. And the base code really has this huge loophole on number 7 under VRF systems installed with a dedicated outdoor air system. There's several concerns about that within, and again, this is a base code issue. So base code has dramatically reduced the requirements here. First of all, understand what VRF systems are. There's multiple types of VRF systems. There's VRF systems that are essentially a cooling only system that just happens to have multiple evaporators connected to the same condensing unit. That's a VRF system. It's classified as a VRF system in HRI by the manufacturers and everything because the refrigerant flow is variable based on the load. That is a cooling only system. Excluding those from an economizer means you're spinning a compressor all year long instead of just opening an outside air damper in our wonderful climate, as like today. Then there's the type of VRF systems that are changeover. They are either a heat pump or they're a heat pump, but they're either heating or they're cooling. So whenever something needs cooling in that building, you got to spin a compressor. The whole idea behind economizers is on a day like this, open the outside air dampers and you got all the cooling you want. Now for what maybe people are thinking about when the words and letters VRF are put next to each other is a heat recovery VRF system. The pretty color brochure of a heat recovery system shows some units in painted red, some units painted blue, implying they can swap heat all day long, and therefore, harvesting the interior heat, distributing it to the exterior, and therefore that's usually the justification for not needing an economizer. However, what's happened with the expansion of these systems into low ambient conditions, which is a good thing. This is one of the things we're happy with low ambient air source heat pumps. But the problem with these VRF systems is that when they're operating as an evaporator with the unit outdoors, they're making a very, very cold refrigerant because they're having to suck heat out of, minus 5-degree air. Manufacturers will tell you, you really shouldn't include zones that require cooling at the same time when you need heating in these extreme conditions, or just in our design conditions. And that's a real problem. It doesn't show up in the color brochures. It only shows up in the installation instructions of these units. And when you talk to manufacturers, they essentially say you can't install a VRF system that effectively swaps heat from the interior to the perimeter. Therefore, and then there's a whole lot of classifications of buildings that are thin or don't have a lot of interior heat to go around during the zone. So this whole question about VRF systems not needing an economizer has just been totally misread by the manufacturers, misspoken by the manufacturers. It doesn't work that way. It can't possibly be better to spin a compressor all year long than it is to open an outside air damper on a day like this. I would recommend that number 7 be struck just like it had been up until the 2021 code.
John, do you want to talk more about that for number 7 there?
Yeah, briefly. I want to give time for other comments. Yeah, that makes sense. I mean, I hadn't really thought about the extreme winter condition, and it sounds like the preference then would be to have the VRF systems, if we remove this exception, that they would have to go performance. So provided that there's a reasonable way to model them, then they would likely have to go performance. I'm okay with that. I don't have too much. I've seen a VRF system in practice, but I don't have a ton of direct experience with them. But I understand the issues of having the interior-exterior issue. It seems like that would be a similar issue with a VAV system in general, though.
Yeah, and I'll jump in. Let me jump in real quick on number 7 as well. I mean, the VRF system with the dedicated outdoor air system, the dedicated outdoor air system is a fan designed to provide just the ventilation air required for the building. And so the code, the 2021 IECC commentary talks about why the exception number 7 was put in there. And the idea is that if we required the VRF system with a dedicated outdoor air system to also have an economizer, that dedicated outdoor air system would then need to be oversized with a larger fan to be able to provide the required air in an economizer mode. And so the IECC demonstrated that, or the commentary expanded that the VRF system, the added cost of that larger fan and et cetera, wasn't necessary for the energy savings weren't there for the VR system. So that's why the exception number 7 is there, is the challenges of getting an economizer air for the VRF systems with only a dedicated outdoor air system designed for ventilation.
Right, and I mean, I think the codes in general, there isn't certainly a perfect energy parity between different types of HVAC system choices, right? But we, at the same time, we don't want to give a VRF system a free pass either. I know that DOAS systems typically have a variable speed drive, although they run at constant volume. They typically use those for balancing. So maybe there's, theoretically a reasonable chance of them being able to size it larger, but I don't know that that's the intent of this. It seems to me like they're, is it reasonable to, I guess, to push VRF systems to the performance approach, basically, is the question. I think that's what it would effectively do.
Well, that's where we are today.
Yeah.
I mean, today, the VRFs, they definitely do not want to provide economizers due to the reasons stated of designing the dedicated outdoor air system to be sized to be able to provide the full air. So they are almost 100% required to go to the performance path, is what we see today, which is the challenge because there's some small projects where you're just doing a small office remodel, et cetera, and they're required to do a performance path, which adds cost to a project. So I don't know where what the right answer is, because I mean, obviously there's some. I kind of like having the VRF system exception the way the code is put in there, because I don't believe it was put in there because of the energy transfer amongst the fan coils. I think it was mainly put in there because of the challenges of actually accomplishing an economizer on the system itself.
Mark, go right ahead.
The challenge of bringing a economizer amount of outside air to a fan coil is the same, whether that fan coil has refrigerant in it or water or is a water source heat pump, that's the same. What I don't understand, well, I do understand it because, you know, the way that the sausage is made, the manufacturers were able to get this exception in, but it's the same issue. If, like you said, Charles, if it doesn't include the heat swap, then it's the same as a 4-pipe fan coil. I find it, what's interesting here is this proposal, the previous version did include the heat swap ability of a water source heat pump system to be included in the regular commercial code as opposed to just the green code. You know, if we're looking to, again, not having an economizer is a less of a requirement than having an economizer. So if we're interested in doing that, the water source heat pump system has a lot better possibility of actually swapping heat between the interior zones and the exterior zones. You still got to do it right. You can still end up with a mostly heating or mostly cooling system, which is why it'd be difficult to put in the base part of the code. So I just find it interesting that it was, if you need to include VRF systems, I would at least make it be required to be the heat recovery type of heat pump system that does indeed have the ability. See, here's the issue: is in more moderate climates, surprise, surprise, you know, California, we don't have to worry as much about -5-degree simultaneous heating and cooling, but here we do. In the interior of a large building, we'll always have cooling zones when it's -5 out, and therefore, if it's a matter of spinning a compressor to do that energy or use that free cooling, anyway, I think I've said, made my point. I'll release the floor, I guess.
All right.
Yeah.
Thank you, Mark. Chuck, go ahead.
Yeah, and I agree, Mark. Number 7, I guess I'm okay either way, whether it stays or goes. I mean, I understand why it's there, but I also understand that there are multiple other systems that are a challenge to provide an economizer air to. Any split system in the inside of the building, any hydronic heat pump, any, there's lots of systems that becomes a challenge. So I'm okay either way on number 7. Jumping back down to the integrated economizer controls, pretty much everything under 2.2 is directly from ASHRAE, but the base code section C4035, the integrated economizer controls in the base code is almost identical. And so I don't see the advantage in pulling the ASHRAE language forward, because section C403.5.1, 1, 2, and 3 are almost identical, except in B, IECC has 75,000 instead of 65,000. So maybe we edit that small portion. And then even the table that's brought forward from ASHRAE is identical to the table C403.5.1 that's in the base code. And so I don't see the need to bring 2.2 forward. Possibly some tweaks with just some of the numbers that are different, but overall it appears to be almost identical. And then my other comment is with rooftop units of a rating of 33,000 requiring an economizer, they're going to require, if they're required to have an economizer, they're required to have fault detection. And do the rooftop units with that small have the fault detection available? Because I know that fault detection is an added feature on most rooftop units, and I just wasn't aware I don't know if their fault detection controls are available on units that small, since they're not part of the base code. And so I don't know if the industry has provided those fault detection on units that small.
Let us note that there's a typo in 2.1 where the BTUs are the same, but I think they're not intended to be. The 2.1 says rooftop units with a rated capacity of at least 33,000, but less than 32,000. So there's just a little bit of numerical editing that needs to be done there.
Yeah, I think it's supposed to be 33,000 and 54,000.
Right, yeah, thank you, yeah, for the correction. There is that typo. So, yeah, I'm not opposed to kind of collapsing this language where it's redundant with IECC and then changing the capacity for C435.1 number 2, change that from 75,000 BTUs down to 65,000. Yeah, as far as the fault detection, I'm not entirely sure. I mean, I think the units should be capable of having that. They have the same number of control points and controllers. I don't know whether they're configured right now to have that as an option or not, but I'm thinking it would not take much for that to be added on as a capability.
All right, I'd like to recognize the time. I'll definitely let you speak up here, Chuck, but let's try to wrap it up and let folks move on with their day. Go ahead, Chuck.
No, I was just going to say that, yeah, it may be capable on the smaller units to be added, but I know like other items we want it to be able to be a package unit, because I know it's an option that's available on the larger units. I just want to make sure that on those smaller units it's available as a package to be purchased that way, because it is an added cost on the bigger units, and I just want to make sure it's available on the smaller ones.
Yeah, that's a good point. I'll have to take that as an action item to verify that.
Okay, thank you.
All right, so sounds like there's a few edits to be done. I think that number 7 is still an outstanding item. John, I wonder if you want to maybe put your heads together with Mark and Chuck and anyone else that's interested, perhaps offline via email, to settle on a direction, whether or not exception number 7 stays or if it's removed. Sounds like we're kind of on the fence on that one. That being said, and other than the other, what I would call relatively minor edits associated with this, I'd like to get a pulse from the group before we conclude today. In general, do folks agree that we should move this forward in terms of amendments to the energy code in 403.5 in these subsections? See a little head nodding. Maybe can I get a little more confirmation or objection to making these changes, or do we feel like it's not ready?
No, I think we're good. I think that exception number 8, ASHRAE 90.1 has an exception number 12 for dedicated systems for computer rooms, and I think that would probably cover those mini splits that we're trying to address there. So maybe looking at the exception number 12 in ASHRAE for 6.5.1 would be a good one to add. But overall, I'm good with this proposal.
Okay, I'm getting that impression, not hearing anyone speak up in contradiction. So with that, we'll go ahead and wrap it up for today. I want to thank everyone for joining. As I mentioned, we will be having one more of these down the road just a little bit. We'll make sure that it gets on calendars and that we get an agenda posted. And if there's any questions, of course, feel free to reach out to us here in the city. You can just send us all an email and we'll look forward to continue working with you. So again, very much appreciated. Thank you for your time. I hope everyone has a very nice afternoon.
Thanks,
Take
Eric.
care.
Thank you.
Thanks, everyone.
Thanks.
Eric, do you have 2 seconds to stay on?